Today, let's talk about parallel lines cut by a transversal.
Two parallel lines, and we'll say that CF is parallel to JK, and these parallel lines are cut by a transversal. Now just note that transversals can look a number of different ways. They can even be perpendicular. The point is that the angle relationships will always be the same, no matter how the transversal looks. But for this example, we will look at a transversal that is not perpendicular to the parallel lines. Now, when a transversal crosses through parallel lines, it creates a bunch of angles. And we want to go ahead and explore the relationships between these angles. Now, if we pinpoint on those two sets of angles, we should notice that they look pretty much identical. In fact, if we take our two parallel lines and overlap them on top of each other, we can see that the angle measures for either line are going to be identical. And this is a very important property of parallel lines cut by a transversal. Now, what this relationship tells us is that when we have parallel lines cut by a transversal, we can say that the corresponding angles are congruent. So if our obtuse angle on line CF were 122 degrees, then our obtuse angle on line JK would also be 122 degrees, again because corresponding angles are congruent.
Cool.
Now here comes the cool part. If you know one of those angles, you can find all of the remaining unknown angles. Let's start out with the angles directly opposite or vertical to the angle that we just found, which was 122 degrees. We know that vertical angles are always congruent, so in this case, the angles opposite are also 122 degrees. Okay, I'm cool with that, but how do we find the other angles? Now, we should remember that angles that are linear pairs are supplementary, meaning that they have a sum of 180 degrees. So if one of the angles of our linear pair is 122 degrees, I can find the other unknown angle by asking the question 122 plus what number would equal 180, which is the same as subtracting 122 from 180, whose difference is 58. So now I know that the supplement to 122 degrees is 58 degrees. And again, I know that all corresponding angles are congruent. And I also know that all vertical angles are congruent. So now I have enough information to fill in the measures of all the angles on the diagram. So now let's go ahead and look at another example of parallel lines cut by a transversal. And we'll try to make some generalizations about the relationship between the angles that are formed. So let's just say that we know that one of those purple angles has a measure of 30 degrees. Because we know that corresponding angles are congruent and that vertical angles are congruent, we know that all of the purple angles have a measure of 30 degrees. We also know that all of the orange angles have a measure of 150 degrees because they are linear pairs, meaning they are supplementary. So 180 minus 30 is equal to 150. And again, this should really drive home the fact that if you know one of those angles, you can find all of the angles. Now, since we are all about visual learning here at Mashup Math, I want to share with you guys something that I call the X's and O's mindset. This is a helpful little technique for you to better understand the relationship between the angles in any situation involving parallel lines cut by a transversal. Now, this mindset involves differentiating between the obtuse angles and the acute angles using some kind of a diagonal mark. So in this case, I have a diagonal orange streak for the obtuse angles and a diagonal purple streak for the acute angles. Next, I'm going to label all of the acute angles with the letter X and all of the obtuse angles with the letter O. Now again, you can reverse this and make the acute angles O's and the obtuse angles X's. As long as you are consistent, this mindset method will still work. Now, with this visualization in mind, we can conclude that all the angles labeled with an X are congruent to each other, all the angles labeled with an O are congruent to each other, and any combination of an X and an O angle will have a sum of 180. So any XO combo represents a linear pair. So now let's go ahead and apply this XO mindset to an example question involving some algebraic expressions. So in this example, we want to find the value of X and find the angle measure of all the angles in the diagram. So in this case, we'll label our obtuse angles with X's and our acute angles with O's. And remember those angle relationships. Now in this case, we can see that our two algebraic expressions are both O's. So I know that I have to set them equal to each other since those two angles are congruent. And now all we have to do is solve. We can subtract X on the left side of the equation and subtract 26 on the right side. We can simplify and come to a solution that X has a value of 6. Now we are not finished here. In order to find the angle measures, we have to substitute 6 back into each expression. Doing that gets us an angle measure of 38 degrees for all of the acute angles, the O's, and subtracting that from 180 gives us 142, which is the measure of all of the obtuse angles, and now we have completed the entire diagram. So you may choose to use the XO method or some similar color coordinating method to better help you visualize the relationship between the angles.
If line L is parallel to line M, what is the value of X? Based from the given conditions, the angle relation is alternate exterior angles. Then, we can say that they are congruent.
So I would set them equal. I would set 3x plus 10, set that equal to 4x minus 10. Well, let's subtract 3x first. That leaves me with 10 is equal to, well, 4 minus x minus 10. And then add 10 to both sides. Leaves me with the value of x is 20. And so if x is 20, then my alternate exterior angles will be congruent, and so the lines will therefore be parallel. We need to solve for x and we need to solve for y. Now in 3 of those angles, 2 of them have an x and only 1 has a y. And so it'll be easiest if we solve for x first. This angle and that angle are somehow related. Now they don't have a good proper name like alternate interior angles, and they're not corresponding angles, they're not consecutive interior angles. So we're going to have to do a little bit of reasoning first. I know that the blue angle and the green angle, if I move this green angle up to its corresponding place, would make a linear pair. So that means that these two angles, the blue and the green, are supplementary. If they're supplementary, that means I can add them together to make 180 degrees. So the blue angle plus the green angle, 3x, I know together those two angles add up to 180 degrees. So solve for x. First we'll go through and collect like terms. I got a 9x and 3x together makes 12x plus 12 is equal to 180. Subtract 12 from both sides gives us 12x is equal to 168. And then divide both sides by 12. That leaves you with x is equal to 14. So I've solved for x. Now it's my job to solve for y. So the angle that includes y is this angle down here, this red angle. And I know that that angle, along with the blue angle, are alternate exterior angles. And alternate exterior angles must be congruent. So the blue angle must be equal to the red angle, 4y minus 10. But we know that x is actually equal to 12. And so we can rewrite this side equation as 9 times 12 plus 12 is equal to 4y minus 10. And then we have to solve for y. Oh wait, x is not 12, x is 14. Oops, mistake. Alright, so 9 times 14 plus 12 is equal to 138, and that equals 4y minus 10. Add 10 to both sides, that gives us 148 equals 4y, and then divide to both sides by 4, gives us that y is equal to 37. So that's one of our answers, and then previously we had that x was 14.
Yes.